In this video, we will compute probabilities using combinations. So let's say that a store has 8 cell phones and 3 of those phones are defective. Let's calculate the probability that a couple purchasing 2 phones receives 2 phones that are not defective. So we have 8 phones, just to visualize. 3 of those are defective. That means 5 of those are not defective. So we want to calculate the probability that 2 phones are not defective. So what are we going to calculate on the top? We want to calculate the number of ways to select 2 phones, and those 2 phones are not defective. So ways to select 2 phones not defective. And then that's out of how many ways we can just select 2 phones. Just total possible ways for us to select 2 phones from the 8. Ways to select 2 phones. So for our numerator, if we want only not defective phones, then we need to only be taking from not defective phones, which would be that 5. So 5, choose 2. Now why is this the choose function? Why is this a combination and not a permutation? Well, because we are just grabbing a group of 2 phones, and it doesn't matter that my phone and my partner's phone are defective or not defective, not defective. That's the same as my partner's phone not defective, my phone not defective. So the order in which we are taking the phones does not matter. It's just simply that we have a group of 2 phones, both not defective. So order does not matter. And then we are selecting from our total of 8 phones, 2 phones. That's our total possible ways to just choose 2 phones if we weren't worrying about defective or not defective. So how many ways could we just get 2 not defective phones? 5, choose 2. There's 10 ways to do that. And then if we were choosing from all 8 of them, how many ways are there to choose 2 phones out of 8? There's 28. So if we simplify this down, we get 5/14 or approximately 0.357 as a decimal. Not great probability if you're randomly choosing 2 phones and you want 2 that are not defective. Let's try one more example. A class of 25 students has 12 freshmen and 13 sophomores. If a random group of 5 students is selected, what's the probability they will all be sophomores? So we want the probability of all sophomores, which means we want the number of ways to select 5 sophomores divided by just the number of ways to select 5 people. So total possible ways. So if we want only sophomores, we need to choose from this sophomore group of 13. And remember, it's just a group of 5. There's no distinction in their roles or there's no order. So we're going to use the choose function. 13, choose 5. Now that's from specifically sophomores. We're going to divide that from choosing from the entire group of 25, because that's our total possible ways to choose groups of 5. And we get a pretty small probability, 0.02, round a little bit further, 0.02422, or about 2.4%. So a pretty small probability that we would get all sophomores in our group of 5 that we're selecting.